In the population and sample video, we learned that usually we can only collect data from a sample, not from the whole population. But isn't that like judging a whole cake just by tasting one crumb?
Exactly. A sample is only a small piece of the story. Descriptive statistics let us describe that piece, the crumb. But what we really want to know is, what does it tell us about the entire cake, the population? That's where statistical testing comes in. Statistical testing is an indirect approach. Our hypotheses concern the population, but we usually cannot observe the entire population directly. Instead, we draw a representative sample and collect data from it. Based on these data, we make decisions about the hypotheses that relate to the population. But because we only observe part of the population, the decision always involves some uncertainty. The good news is that this uncertainty can be controlled. We choose it to be small enough that our results are scientifically useful, though it can never be removed entirely. There are many statistical tests for different situations and data types, but they all follow the same principle, a structured procedure of 5 essential steps. 3 steps are completed before data collection and the remaining 2 afterwards. This framework ensures that statistical testing is transparent, objective, and reproducible.
So far, I understand that we need to use sample data to make decisions about the population. But how do we actually do a statistical test step by step?
Great question. Every statistical test follows 5 essential steps. Let's go through them. Step 1 is to formulate a hypothesis pair based on your research question. This pair consists of the null hypothesis and the alternative hypothesis. The alternative hypothesis reflects your research interest, while the null is its logical opposite. Only one of these can be true. There is no third option.
So the null is basically the no effect or no difference scenario.
Exactly. Step 2 is to set the significance level, also called alpha.
And what exactly is alpha?
Alpha is the central criterion for making your test decision. It's the maximum acceptable probability of making an error when rejecting the null hypothesis if it is actually true. In other words, it's the risk you're willing to take of a false positive result.
So it's a preset limit on the probability of a false positive, right?
Precisely. And here's the important part. You must set alpha before collecting any data. That way, your decision remains objective and free from bias. If you waited until after seeing the results, you might be tempted to adjust alpha to fit the outcome, and that would undermine the integrity of your test.
What values are common?
Often 0.05 or 0.01 comma, but the exact choice depends on your field. Step 3 is to choose the correct statistical test for your research question.
And how do I know which one to pick?
It depends on the characteristics of your endpoint. For example, the measurement scale, the distribution of the data, and the type of sample you have. These factors guide you to the most appropriate test.
So after choosing the right statistical test in step 3, I guess the next thing is to actually collect the data.
Exactly. Once the data is gathered, we move to step 4, calculating the test statistic and the p-value.
Ah yes, the p-value. I've seen that mentioned in scientific papers, but I've always wondered what it actually tells us.
It shows how likely your observed data would be if the null hypothesis were true. In other words, it helps you judge whether the data is compatible with the null hypothesis.
So a small p-value means the data doesn't really fit with the null hypothesis and instead points more towards the research hypothesis.
That's right. And that leads us to step 5, making the test decision and interpreting the results. If the p-value is smaller than your chosen alpha, you reject the null hypothesis. Otherwise, you stick with it.
So everything we've done, the hypotheses, alpha, test choice, and data, comes together in this final decision.
Precisely. It's the moment where statistical reasoning meets real-world interpretation.
In the beginning, you said statistical testing helps us go from a small piece of information to understanding the bigger picture.
Exactly. And by following the fixed steps before and after data collection, we make that bigger picture as accurate and unbiased as possible.
So the method is what turns limited data into reliable conclusions.
That's the essence of statistical testing.